All right, let's dive right in. Today, we are pulling back the curtain on the incredible journey from just brute force metal bashing to incredible digital finesse. We're talking about the secret science behind one of the most essential components in the world, something you absolutely rely on every single day, probably without even thinking about it.
So let me ask you something. What in the world connects the massive, slow-turning blades of a giant wind turbine to the screaming, high-revving engine of a race car? I mean, they couldn't see more different, right? Polar opposites.
Well, the answer is the humble gear. But the real story here, the fascinating part, isn't the gear itself. It's how it's made. We're about to uncover the mind-blowing science and precision engineering that turns a simple hunk of metal into an absolute masterpiece of mechanical perfection.
First off, let's talk about mastering metal. And don't think of these as old, dusty methods. Nope. These are the powerful, super refined techniques that really form the bedrock, the physical foundation of modern gear manufacturing.
So, how are these classic techniques getting a modern upgrade? Well, take hobbing, for example. Think of it like carving a gear out of a spinning metal cylinder. Now, it's way more efficient, with tools that last much, much longer. Then you've got grinding, which is all about getting that perfectly smooth mirror-like finish. Today, it's so precise it can actually be optimized to reduce noise and vibration. And for the really complex stuff, like skivvying and broaching, you've got advanced computer models and algorithms guiding the process, making it faster and more accurate than was ever possible before. And here's the proof of just how big an impact this makes. Research by Kamchatna Stepanova and Klochko found that modern high-speed milling can cut down on labor and material use by a factor of 3 to 4 times. That is a huge leap in efficiency and sustainability, all just from perfecting these foundational methods.
Okay, so while those classic methods are being perfected, a totally different approach is showing up on a new frontier: additive manufacturing. Yep, we're talking about 3D printing gears, an idea that is basically rewriting the entire rulebook.
So, how does printing really stack up against traditional carving and cutting? Well, traditional methods, what we call subtractive manufacturing, they are the undisputed champions for mass-producing high-load metal gears, no question. Additive manufacturing, on the other hand, it really shines when you need to create complex prototypes or small batches of custom parts from polymers or even specialized metals. The challenges are totally different, but the potential is just enormous. But, it's not without its challenges. Researchers like Zielkowski are finding that tiny details in the printing process, like the height of each layer, directly affect how quickly a gear wears down. And as Calignano's work points out, even the quality of the recycled powder used for printing can mess with the gear's final accuracy. So the takeaway is clear. Making printed gears reliable means having an intense, almost obsessive focus on process control. And this brings us to the real revolution, because it's not just about one method versus another. The biggest leap forward is happening in the digital world, where the physical machine meets its virtual twin. And the core of this whole thing is something called the digital twin. Okay, so what is that? Imagine a perfect virtual copy of a gear-cutting machine living inside a computer. Now, this virtual model gets fed live data from sensors on the real machine. This lets engineers predict problems before they happen, test out changes, and optimize the entire process, all in the virtual world without wasting a single piece of metal. This quote just sums it up perfectly. Manufacturing isn't just a physical act anymore. It's become a dynamic, real-time conversation between the machine doing the work and its digital copy that's constantly learning and adjusting. It's pretty amazing. So what does this digital brain actually do? Well, it does some incredible things. For example, Xu and his team built AI models that can predict how heat will expand parts of a machine and then proactively compensate for it to maintain incredible precision. It uses algorithms to correct for tiny misalignments on the fly. It even uses virtual models to teach inspection cameras what a perfect gear should look like. This isn't just manufacturing, it's intelligent, proactive manufacturing. And this digital intelligence goes all the way to the very final touch. Even after a gear is perfectly cut, a process called stream finishing can take its surface to the next level. Imagine a gentle, flowing stream of abrasive material polishing the metal to an ultra-smooth finish. This tiny detail makes a massive difference, helping lubrication spread more evenly and dramatically boosting the gear's durability under extreme pressure. So where does all this leave us? After this whole journey into the science of making gears, what's the big takeaway here? What's next? Here's the most important point. The future isn't a choice between classic cutting or modern printing. It's about the sophisticated fusion of all these amazing physical processes, all of them guided, corrected, and perfected by this incredible layer of digital intelligence. Which really leaves us with one last big thought. We've seen how AI and digital twins are helping us create practically flawless mechanical parts. So the question is, where else could this incredible fusion of the digital brain and the physical world take us next? What other industries are right on the edge of being completely transformed by this? It's definitely something to think about.